So in this video, we will be doing the prefix sums algorithm in computer science, which essentially allows us to find the sum of a contiguous subarray of all the elements of a contiguous subarray. So pick an index to start at and find the sum of all the elements up into the end index. So it allows us to find that sum in linear space. So again, what do I mean by contiguous subarray sum? Let's say I have 2, 3, 4, 5, 6. We choose these numbers because they're simple numbers, right? And let's say these indices obviously correspond to 0, 1, 2, 3, 4. So basically, what prefix sums allows us to do is, let's say I want to choose a starting index. I can find the sum of all the elements from the starting index all the way to anything that I wish to end on. So let's say I wish to end on the third index, right? Or so then I could also do this maybe for the second index. I can essentially do it for anything we want. Now, we don't, in both of these examples, I started from the 0th index. This doesn't necessarily have to be true. We can modify the initial implementation of prefix sums such that we can find what is called a carry range sum, where we choose like a non-zeroth index to start from. So we can choose like 1 and find the sum from 1 to 3, or like 2, find the sum from 2 to 3, or 3, find the sum of 3 to 4. So that's basically what we can modify, but we'll worry about that when we talk about prefix sums. The first thing I want to talk about is how would you approach the contiguous subarray from 0 to 2, the contiguous subarray sum from 0 to 2, so the sum of all the elements from 0 to 2. This is probably what you would do if you didn't know prefix sums existed. You would first calculate one array 0. So the first step you do is calculate array 0. So you're going to loop through array 0, and you're gonna say, okay, now loop through 0 to 1, right? So we have to recompute 0. So we have to recompute array 0. And then we're gonna basically say recompute what we already did in step 2. And then tack on array 2 to find the sum of the indices from 0 to 2. So there's nothing inherently wrong with this method. In fact, since it's a small array, I mean, you probably don't even need to be extra and like implement an entire method to do prefix sums on this like interval sum from 0 to 2. Since it's a small array, it doesn't really matter. But I'm trying to emphasize that as your sizes get bigger, this method is not good. And why is it not good? Because think about it. After each step, when you're looping through this, and then you break the code obviously at the index you want to end on, when you're looping through this sum, you're recomputing values. Like in step 1, we recomputed array 1. Notice how step 2 nests in step 1. So we're recomputing step 1. We're recomputing array 0. Same thing for step 2. We've computed this thing. We've computed the sum from 0 to 1. Now what we're doing is we're computing that again. So we're computing that again. We're computing step 2 and step 3. And this is essentially the only thing we don't compute again, which is obviously the ending index. So that's the problem with this. There's nothing inherently wrong with it. It's that it's not efficient. So when our array sizes become very large, we need an efficient time, so like O of n, linear space time, to do this so that we don't have to keep being redundant with recomputing these values. And that's exactly what prefix sums allows us to do. It allows us to essentially eliminate this redundancy and essentially find the sum in linear time, in linear space. So let's take the same subarray, or not subarray, let's take the same array. So 2, 3, 4, 5, and 6. And this time we're going to set this array to an array called A. So this array, let this be an array called A. And then we're going to have an array called P. Basically what's going to happen in P is we're going to first claim that let the index at, in fact, let me just do this in black. Let the index at 0 of array A equal the index at 0 of array P. And P is our prefix sums, okay? So P is a prefix sum array. So P is a prefix sum array. So we're going to let the 0th indices be equal. Now, essentially, what we're going to do is the last method, we noticed that we had redundancy because we kept recomputing steps. We kept recomputing values like array 0 and array 1. So what if we could say that when we compute these values like array 0 and array 2, when we first compute a step, we store that step. right? We don't have to reiterate through the same step when we go to the successive step, when we go to the next step. So when we compute array 0, we grab it and we store it. When we compute array 1, we grab it and we store it in some array, so we can simply refer to it and we don't have to essentially recompute it. Like we're not reiterating. We're just checking each individual index. So when we check the first index, we're done. We don't have to recompute that. When we check the second index, we're done. So that's essentially what this is going to do. It's going to eliminate this redundancy. So what I mean is that we have this prefix sum from 0 to 0 is obviously just 2. Now we're going to say we already have this. All we need to do is just add this new element over here. We just need to add 3. Because it's already being stored. We already know the value of p of 0. It's 2. It's stored in some array. So then all we need to do is really just check this index, which is 3, and just add it onto there. So the same thing over here. We're basically going to say, well, just do 2 plus 3, and then add this new element over here. So add the element over there. And then just do 2 plus 3 plus 5. And then add the new element over there. So add this new element. And so on and so forth. So you can just do this, and then we could also do it for 6. But the point is, I don't really care about doing it for all of them. The idea is that this prefix sum array, the efficiency behind this is that when we when we compute values like a of 0, like these are all the computed values: a of 0, a of 0, a of 1, a of 2, a of 3, a of 4. We can essentially grab these values and just like store it in some array, and we can have a very quick reference, right, to the other values, because the other values, the new elements, are stored in array A. So how would we actually implement this? Don't worry, you'll understand this, especially when we implement it. But how would we implement this if you wanted to like think about this more generally? Or how would we generalize this? So let's say I want the prefix sum at the ith interval, at the ith index. So I want p of I. How would I do this? So basically what we're going to do is intuitively we're going to take the previous prefix sum, so p of I minus 1, and after we do that, we're going to add it to the new element, which would just be a of I. Because notice that the length of a and the length of p are the same. So the idea is that we start from the previous prefix sum and we simply just add it to the new element. Like, just let's do an example to make sense, right? So this is only generalized when I is between including 1 and then between n, where n is the length of the array. So n is length of array. Okay, so this method is only generalized in this case because we've already set the 0th index, right, to a of 0, so we don't have to worry about that. So basically, how do we make sense of this, right? Let's say I plug in 1, right? Let's say I want to find the prefix sum from 0 to 1, right? So the prefix sum from 0 to 1, all we're going to do is we're going to find the previous prefix sum, which is p of 0. So we're going to take this 2. So, and then we're going to add it to a of 1. We're going to add it to 3 over here. So we're going to add it to a of 1. So it generalizes, it checks out. Basically, we're starting from the previous index of this array, and then we're adding the index ahead in this array over there. And we can essentially just generalize this to everything. So that's basically what we do. Now, this is if we start from the 0th to the to the ith index. What if you want to start from the ath index to the bth index? Basically, if you want to find an interval sum, and we call this interval sum a carry sum. So what if you want to find a carry sum or interval sum? Basically, what I'm saying is that let's say, like in this example, right? What if you want to find the sum from let's do the sum from like 1 all the way to 3, right? If you don't want to start at the 0th index, well, basically you would do the same thing. You would basically just use this. You'd say find the sum of p of 3, right, and subtract all the sums we don't want. So basically we don't want this sum, right? This sum is going to ruin everything, so we just subtract p of 0. So that's basic. And so notice we can generalize this. We say if you want the sum from a to b, right? If you want the sum from a to b, and given that a is less than b, given that this statement is true over here, then what we do is we simply just find the sum of the prefix sum of b, right? We find the sum, and we will eradicate all this. We basically eradicate the sum, that the sum that precedes a. So we eradicate the sum that precedes a, because think about it. The a minus one interval essentially contains a sum from all the elements from 0 to a minus 1. We do not want those things there, because we only want the sum from a to b. Thus, when we compute the sum of p of b, we eradicate the sum from 0 to a minus 1. Therefore, we're only left with a to b. So that's how we do it for the Curie sum. Now, how would we implement this prefix sum idea into Java? So the first thing we're going to do is import a scanner. So do Java, so scanner, oops, okay. So import the scanner, and basically we're going to take in a length for the array. So first we have to actually make the scanner. So my bad, let's make the scanner first. Okay, so take an input from the user, system.in. So we're basically going to say, and this was already run previously, don't worry about this. This is actually the test case, by the way. Do not worry about this, actually. Okay, good. So we're going to take in, we're going to obviously take in the length of the array. So first take in n. So let's say in n is equal to sc.next int. So this is basically going to equal to the length of the array. So length of array. So then we're going to say let a new integer now. Let a new integer. So no, let a new array. So let array a be a new array. So no, I want capital. Bruh. Okay. Okay. Bruh, is this not working? Okay. Oh, so let this be new int, and then we're gonna size this to n, obviously, because n is the length of the array. So basically, this is going to be the original array with all the irregular elements. And then we're gonna say let's make a new array that's basically gonna store all the prefix sums. So let's say this is a new array that's gonna store all the prefix sums. This has the same length. We're gonna make it the same length, obviously, and we're gonna say this is gonna be the prefix sum array. There's other implementations where the length is actually n plus 1 for prefix sums. That's because they store in 0 for the first index. I personally think it's just easier to not do that. Just let the indices at the 0th indices be equal, but don't worry about that. So let's just let this be the prefix sum array. Okay, so after we do this, we want to actually take in elements for the array A. So let's take an element. So let's say for int I is equal to 0 all the way to the n minus 1th index, all the way to the n minus 1th index. So we increment this. So all of these, we're going to actually take an input for the elements for A. So we're going to say at the ith index, right, return the user's input. So return sc.next int. And then basically, so we're going to say it contains A's elements. So that's what we're going to do. We're going to take in user. Now we're first going to say that, okay, after we've taken in the input, let the index at 0 of array A be the index at 0 of array P. Because remember, that's what we did over here. We let this statement be true. All right. Now what we can do is don't worry about the interval sum. We'll worry about that later. We're gonna first implement it if you just want the 0th to the ith interval. Okay, so we're essentially going to make a filler method, so a public static void method, so just to fill in the stuff. So we're gonna make this a method called prefix sum. You'll see what we do. So public static void and then call this prefix sum. So pref sum or prefix sums, whatever. So we're going to pass in we're obviously going to pass in, let's pass in A. Yeah, obviously we're gonna pass in all the parameters. Not obviously, we have to. Let's see, nothing break. So so pass that in. So pass this in, pass n in, and then basically after we pass these stuff in, what we want to do is we want to implement what is the prefix sum. So we basically said the prefix sum is equal to p of I. So no, first we need to loop through the indices. So first we have to loop through the indices. So, and we're only going to loop from 1 to so the generalization is we're going to loop from I knew I wrote it down somewhere. We're only going to loop from 1 to n because we've already set the 0th index. So loop from 1 to n. So let me also so set 0th indices equal. So we're gonna loop from 1 to n. So or technically n minus 1. Because yeah, obviously n is the length, we can't have a of n out of bound exception. So then basically after we do that, we're going to say at the ith interval, so p of I, basically we want p of I minus 1, and then we want a of I. That's basically what we talked about. We're just implementing what we did into Java. So after we do that, we're going to now say, well, we can refer to the main method. Basically we can say system dot first we can now first now actually not we can refer to the main method. We can say fill in the array, so fill in the method, I mean, so fill this in with a, p, and n. So fill this in with parameters. Okay, so fill this in with parameters. Basically, what this allows us to do is it essentially it allows us to like fill in the things, because we like when we put this void method, we don't actually know what these things are. The user is going to like input these. So when we do prefix sum of APN, we're essentially just filling in everything, right? We're filling in A, P, and N. That's basically what we're doing. Because imagine if you wanted to reuse this again and without user input, then we could just do fill in a new array and p of n. So that's what we have to do. So fill it in with parameters, and then we're going to basically say, we're going to say that we want to print out all the possible prefix sums. So print out the possible prefix sums. So the prefix sums are going to be from I to n, I plus 1 plus, and we're going to say we want to print out system dot out print, and I actually want to print them on the same line. So so we're going to say prefix sums are basically, they're going to basically just be, they're going to be p p of, or whatever, just remind if you have a space there. They're going to be obviously p of I. We've already done that. We've already done the hard part. We just have to implement this. So let this be p of I. We want a space after each iteration to make it look nice. And that's basically going to be the sum. So let's recap what we did. We first took in the length of the array. We made a new array, so that's the original array. Then we made the prefix sum, then it contains A's elements, this loop. And then basically we set the 0th indexes to be equal. Then we said, let this be the filler in method where we just pass in A, P, and N. And we say, when we pass in A, P, and N, we want to make this void because we're not returning anything. Let this be the case over here. And then after that is the case, then we basically loop through it and print out the prefix sums. So let's test this to see if it works. It should work. Be weird if it didn't work. So yes, it does work. So let's print out two. Let's say the length of the array is 5. So our test case should be this. So our test case, obviously we worked with 2, 3, 4, 5, 6. So the array length is 1, 2, 3, 4, 5. So print out 5. The elements, right? The elements are going to be 2 to 6. So they're going to be 2, 3, 4, 5, 6. Now it's going to oh, actually, like, I don't really need this bit. It's going to iterate. I don't. Okay, so yeah, okay, so it obviously it works. So that is good. It works. Um Hold up, let me, like, I don't want this. Hold up, let's do this. Okay, so let's just do this again. Okay, so let's just rerun it again, my bad. Okay, so we want 5, 2, 3, 4, 5, 6. Prefix sums are 0. Wait, why is it printing out 0 for the prefix sum? What? What? I'm okay. This is weird. Hold up. I think maybe you have to do this actually inside here. Most likely it. Sorry for not talking. What? Alright, let me figure this out. This is being. I don't understand why this isn't working. Hold up. This out. All right, guys, I was botting. I figured it. I figured out my mistake. I was like, what the heck did I do wrong? Okay, it was this line. Okay, so yes, Java is just dumb. Like basically, like when I did this. So I said this is equal to p of 0. It works now, as you can see. It obviously works. Let's make sure, yeah, it works. So basically I said this. Okay, the problem with this is, I remember Java is just stupid. But basically what the difference between this and this, right? This is the correct line. Is you're saying store the value p of 0 at a of 0. Store the value of p of 0 into a of 0. Well, p of 0 currently holds nothing. We haven't actually assigned it to anything, right? Like Java doesn't know what p of 0 is, but it does know what a of 0 is. So if you want to not actually let them be equal, you just want to assign the value of p of 0 to a of 0. So be very careful with that line of code. I just messed it up unknowingly. It's a good thing I made that mistake on camera, because you will see that like other people will make that mistake as well. It's very easy careless mistake to make, is that you're assigning this value a of 0, which Java does know, into p of 0. So yeah, that's why. But it works now, so let's go. Now what we're going to do is, since we have the sums, the prefix sums, we actually want to do, what if we want the interval sums and stuff like that. So what if we want to do the interval sums? So basically what we can do is we can say take an A, so where A is the start of the interval. So interval sums. This is also called a carry sum. So taking this, so this is start of the interval. Okay, um taking B, let's see dot next int. Okay, all right. Taking this. Now basically if we want to find the sum from A to B, all we have to do is this. So we could make a new method. In fact, I think I will do that. Make a new method called sum of interval. So let's make a new method called sum of interval. In fact, let us not make them, yeah. So let's actually make a new method and take an input there. I think that's just neater. So let's just do public static void sum of interval. All right, we're gonna pass in a. We're gonna pass in a, or actually, all we need is p. We actually don't need anything. We just need p, because you'll see why. So we're just gonna pass in this parameter. That's actually all we need, conveniently. So after we do this, so basically, we're going to say that we're gonna take an input for these things, and we obviously like. why is void isn't for the variable sum of n? No, okay. So now we know that we basically, or actually we want to return this. So we want to return this because we're returning a sum. So return duplicate duplicate variable end of p. Okay, whatever. We'll worry about that later. So return p of b minus p of a minus one. So get get rid of the stuff the stuff that preceded a which is the start of the interval. Let me figure out these errors off camera so I'm not wasting time. Hold up. Alright, I figured out the value, but give me a second. I actually have to talk to someone right now. Right, I'm back. I'm sorry for the interruptions. But yeah, I figured instead of making this a return type, well, actually, what? Let's just make it void. So make it void, you know, so that way we can just print out. So I'll just say this is the end of the interval. Yeah, implementing this is a kind of a pain. I need to work on those skills. But we'll just say that in carry sum, right? We've already figured out all the hard part. We just have to implement it. So, and now what is going on? Isn't void is an invalid type for the variable sum of interval. This is just the name of the method, though. Hold up, give me a second. I don't even understand why this. Okay, honestly, we Java is actually we don't actually let's not even use this method. I'm botting on this implementation. So honestly, let's not even do this because I don't want to really waste my time. What we can do though is we can just say over here. So let's just pass in them. Let's just say let's pass them in. So hey yo, you're looking at me struggling. It's fine. I'm sorry, this is not the smoothest implementation start of the interval. So instead of doing this method, I thought it would be neater. Let's just not make a method. Let's just put this in the main method. We don't really need a method for it anyway. All right. So basically, we say the int carry sum is equal to p of any p of b, because obviously then p of a minus one. So get rid of stuff that preceded a. Essentially, what we're doing, informally speaking. Then we want to do system, and actually, basically, we want to take this these inputs. We want to take them not we want to take them like more neatly. So let's take them over here. So then we can, do that. Okay. This should work. If it doesn't work, then sheesh. Carry some. In fact, I wouldn't even like do. I'll just carry some. So yeah, basically this is basically what I did to implement it. So I thought it was gonna be nice to just maybe make some sort of method, but as you can see, I was struggling with that because Java is stupid, and that's just not. I'm stupid, but like, yeah, I was struggling with doing that, and so I basically just did int a. I took an input for a and b, and then I just take this carry sum is p of b minus p of a minus one, and we're simply just gonna print that out in the main method, and that should work. That should work. It should work. Yeah, seems fine. Seems fine. So basically, let's print out 5, 2, 3, 4, 5, 6. Print these out, and then it prints it out on the same line. So 2, 5, 9, 14, 20, and then we're gonna print out. Let's say we want the sum from I don't know, from 1 to let's say we want it from 1 to 4, okay? Because then we should expect 18. So wait, no, I want it from 1. Okay, we did 1 to 3. So 1, 2, 3. 1 to 3 over here. So 2 plus 3 plus 4 plus 5, and that is 12. So yep, that's basically how you implement it. I'm sorry, the implementation was very unsmooth, but yeah, basically this is the implementation. And stay tuned for more videos in the future. So